Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Stephanie Glenn, your host. I'm the Editorial Director at Data Science Central, and I'm also the creator of statisticshowto.com. I'd like to start our event off today by thanking Tableau for sponsoring today's event. Tableau is a long-time supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Today's webinar is entitled Advanced Mapping with Tableau, and it's going to be presented by Tableau. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We'll have one presenter who I'll introduce in just a minute. There'll be a 10 to 15 minute Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. I'm very pleased to introduce today's speaker, Kent Marten with Tableau. Kent Marten is the lead product manager for Maps at Tableau, including all things spatial. Kent has worked on mapping software for the last 14 years and is confident the next few years are going to be the most exciting. Thanks for being with us today, Kent, and we're looking forward to your presentation. Every dataset contains a where component. For organizations that need to use location to drive their business, it's critical they can unlock the where in their data. In today's Data Science Central webinar, find out how Tableau can help you work with spatial data and answer location-based questions. Today's webinar will cover several topics, including connecting and joining data to common spatial data sources in Tableau, like Shapefiles and SQL Server, different ways to look at the spatial distribution of data, using advanced operations to understand spatial relationships and spatially aggregate your data, examples of interaction-based analysis and exploration, and options integrating with ArcGIS Maps and providing the right context for geospatial analysis. Ken, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thank you, Stephanie, and thanks everyone for joining the webinar. So yeah, as Stephanie said, I lead the mapping effort at Tableau, and we have a lot to cover in this webinar. We're going to be talking about advanced mapping topics, but I know that some people may not have as much experience with Tableau, so to get started, I'm hoping we can do a little bit of a poll with the audience. So I want to understand your familiarity with Tableau, and I'm asking you right now if you can participate in this poll and let us know what version of Tableau you are using, or if you haven't used Tableau before. The most recent versions of Tableau, the 2019.1 release, is available right now, and of course we have the quarterly releases from 2018. So feel free to enter in your vote in the poll, and this will help me understand sort of the experience level of the group that's listening in right now. I'll give that just another moment before we look at the results and move forward. Okay. Thank you for participating. I can show what's come up here in the in the quick return, and we can see that some people are using the latest version of Tableau and almost equally spread with the group of people who haven't used Tableau yet. So with that in mind, I want to make sure I can cover a number of demonstrations that will show and introduce Tableau and then dive into some of the more advanced topics. Here's the full list of demos I'm going to do. I promise this will be the last slide, and we're going to jump into the software and see how you can make maps in Tableau and answer a number of specific types of questions with the product. Let's jump right into it. This is Tableau, and I'm looking at a very simple visualization that shows sales by state in the United States. Now this sales data is just for a fictitious store called Superstore. And I'm going to show you how easy it is to build a view like this. I'm going to go ahead and clear the map and start from scratch. Now one thing you're going to notice here on the left-hand side of the view, I see all of my data sources that are connected to this workbook. I see all the fields that are listed as dimensions. These are categorical fields. And then I see all the fields listed as measures.
Ken,
yeah.
We have a technical issue with the screen. Could you hold on just one moment, please?
No problem. Let me jump back here, and maybe Stephanie, you can just confirm you can see the screen.
Yes, I can see the screen, so we can continue.
All right.
We can see it now.
Sorry for that.
Ken.
So yeah, let's just quickly review what we're looking at here on the screen. And I have to assume you didn't see what I showed previously, but I'm going to build up a map that shows sales or profit by state in the United States. And just to acquaint the folks who are not familiar with Tableau, here I can see all of my data sources. And for each data source, I can see the dimension fields and the measure fields. Dimensions are like categories. Measures are things that I could sort on or do math against. A lot of numbers. And then I have parameters here at the bottom. Parameters are objects that allow me to change what's displayed on the viz by specifying a certain value in the parameter. I will show examples of this as I go through. If I'm going to build a map, well, I need geographic data. And the source of this data is actually just an Excel spreadsheet. But of course, my spreadsheet includes a state field, and I simply double-clicked on the state value, and that produces a map showing all of the individual states in my data set. So again, Tableau is able to recognize a geographic place name and produce a map on the viz with a simple double-click. I want to show you all of the geographic regions that Tableau supports built into the product. So if you have an Excel spreadsheet that includes airport codes or a list of cities or countries and common administrative districts for the area of the world that you're looking at, whether they be states or provinces, counties or districts, zip codes or postal codes, Tableau has these geographic data sets built into the product. So you can see it's going to be very easy to build maps in Tableau. Now if I want to go ahead and look at profit by state, I could drag profit onto size and proportionally symbol the map. So allow my to perform some visual analysis. I can see proportionally how the states are doing with respect to profit. Of course, if I bring profit onto color, look how Tableau reacts. It changes the map from showing proportional symbols to showing the filled representation, which is an easier way of looking at this view. And this is a core pleth map. So again, this is a very simple way to work with geographic data and all of the metrics and measures that you're interested in. Just drag and drop them onto the viz to create the visualization you're looking for. Now, an interesting thing about Tableau and an interesting capability is that it can also create custom geographies. So in this particular data set, I have a field called region. Now region is just a hierarchical geography. It's made up of states. There's a hierarchical relationship there. Now region could be sales territories, it could be trade areas, but so long as they're made up of underlying well-known geographies like states or counties, you can visualize this on the map. If I drag region onto color, you can see those regions. I'll flip to the map type, and you can see there's 4 distinct regions in this data set. But I'm still showing all of the individual states underneath it, and I'm going to bring the profit onto the label. But watch, as I remove state from the viz, see what happens. the viz automatically updates to aggregate all of the profit into those custom territories. Now, how did I create this? How did Tableau know that this was geographic? Well, from the geographic role menu, you can always say create from an underlying role that already exists in the dataset. And so with state already in this table, I can easily create this new role. Custom territories allow you to build sales territories from zip codes or define custom geographic regions from already built-in datasets. So this is sort of the simple mapping. Let's jump into more advanced topics in Tableau. One common question that people always try to ask with maps is, how do I understand the distribution of my data? Where is there a concentration? In this particular data set, we're going to look at oil and gas wells in southern Louisiana. Now, there is a lot of activity, but the first way in which you might explore or display the data is simply show the raw data values. Right? I can simply see from this view that there's just a ton of oil and gas activity in the southern part of Louisiana. But if I want to understand and aggregate this data to show it at a little more coarser level, well, I might use a few different techniques to do that. The first of which might be to produce bins. So from that data set, which is all displayed, all of those points are displayed showing the latitude and longitude, or sort of using the latitude and longitude of each individual point, I can go ahead and build a calculation that does a simple rounding of the lat long. In this case, I'm going to round the longitude value by a dynamic parameter value. So I could choose to truncate the precision of my latitude and longitude so that it forces those points into their geographic bin. So binning is a common way in which now I can easily see sort of the areas of concentration because I've defined the color scheme for this viz to show certain colors to represent where there is more of a concentration of points, a higher number of points. So square bins are one way you can do this in Tableau. Another popular way is with hex bins. So in Tableau, there's a way in which you can create hex bins yourself. If I look at this view, I could type in hexbin X and Y. These are two functions available in our calculation editor that can allow you to create your own dynamic hexagonal bins. So that's one way in which you can create them. Or for those of you who are familiar with mapping applications like ArcGIS or QGIS, you can create your own hexagonal tile set and then keep that as something that you can join your data set against. So that's what I've done in this case. I've gone ahead and created my own spatial data set of hexagonal grid for the region, and then I've just joined that in with the data set. Again, I can explain in detail how this works, but that's just an example of how to understand distribution. Another way you can look at this, again, it looks very similar to that first view where we were looking at the raw data, but this is actually showing the individual oil and gas fields. You can see these aren't points, but they're very small geographic regions. Right? These are all the actual oil and gas fields in southern Louisiana. Now, depending on your audience, you may be showing a square or hexagonal bin is appropriate, but if you work in the oil and gas industry, you might want to use the actual oil and gas field geographies to show where there's a concentration of oil and gas activity. I can also use dynamic filters to simply reduce the clutter from all those fields that only had a few number of oil and gas exploration taking place and bring that view down and see where is the highest concentrations using the actual geographies in place. The last example I want to show for how to answer the question about distribution is to visualize things with a heat map. So the heat map, unlike the latitude and longitude bins, which are sort of precise, right? The bin represents exactly what falls into that geography, whereas the heat map is more of a smooth surface and really represents overlapping concentrations on a gradient and not necessarily a precise location. For instance, if I had 1,000 wells that represent the outer ring of this red area, well, the whole area is shown as red, even though there might be a specific spot in there that doesn't actually have a well. But heat maps are a very quick way to understand the concentration and potentially the hot spots for activities in your dataset. So looking at all of these together, again, you can look at raw data, ways in which you can bin data, use custom geographies from your own spatial datasets, or use heat maps inside of Tableau to understand the concentration of your datasets. Now, one thing that often comes up when talking about spatial data is, where do you get spatial data? Where does it come from? Well, the world's open data movement has provided so much of this content available free for use. In the United States, there are two common places where I go and look for spatial data. First would be the census. And from the US Census, I can go to one of their download pages and I can pick the geography that matters to me. If I want to look at demographic or socioeconomic data, I might look at census tracts or block groups. If I'm interested in looking at some data related to schools, I might look at school districts. Again, there's lots of data in here that would be very useful if you're looking for custom geographies that are not built into Tableau. And then, of course, you could go to data.gov and simply type in shapefiles, a very common spatial file format, and find 15,000 entries with that very generic search query. Of course, I could type in something like City of Chicago bus routes and also find data sets. But of course, this isn't just for the United States. If I go around the world to these open data sites or these government sites here in Australia, again, the same thing. And I know there are so many out there. So one best practice is simply Google the object that you're looking for. Maybe it's crimes in the place that you're interested in. Maybe it's London, like bike thefts or something, and just hit enter in shapefile or download into the query. So it's very easy to find this kind of data if you don't have it. Now, lots of organizations have their own GIS departments, or they have their own spatial data infrastructure. They receive data all the time that includes latitude and longitude. So you may already have a lot of this data already, and you just need to unlock it. So when we talk about working with spatial data in Tableau, I want to show you what you can connect to. What are the actual data sources that are supported in the product? When I click on Spatial File from the Connect to Data menu, here I can see all of the files that are currently supported in Tableau 2019.1. So there are Esri file geodatabases and shapefiles, GeoJSON files, the KML format that's popular, that Google popularized for use with Google Earth, MapInfo formats, and TopoJSON. So all of the common file formats where people store native spatial data are available for use and connection in Tableau. Now, if you have spatial data stored in a SQL Server database, that is also supported in Tableau directly. And in the upcoming 2019.2 version, which is in beta right now, we're going to look to test out support for Postgres spatial data. Now, I should say, with the 2019.2 beta version, it's possible that we won't ship any of the features that we're testing because we want to make sure that we hit the quality bar for our software. But know that we understand it's very common for people to work with SQL Server and Postgres and so forth. So that's why it's going to be available to test. So let's jump back to my data set and actually work with one of these shapefiles. When you bring in a shapefile or a spatial file in Tableau, you get this geometry field. So it's a special field that includes all of the data related to the spatial object. I can simply drag it onto the viz. And here I'm looking at watersheds for the state of Minnesota. So watersheds are very complex geographies. I can bring on the major name onto detail to disaggregate the data. And you should know, like, this is not going to be a data set that we build into Tableau, right? Tableau has built-in data for administrative data and sort of common place name type data. But for this kind of data, we want you to source it yourself and use it. And it's certainly easy to get and freely available around the world. So with watersheds, what are the types of interesting questions I might be able to look at? Of course, in the state of Minnesota, I was doing some research, and I found that there are a number of possible hazardous waste sites, sites that may be hazardous, right? And here they are, all of these point locations scattered around the state of Minnesota. But if I want to understand the concentration of these waste sites in terms of which watershed has the higher probability of having some contamination occur, and contamination of the waterways in that area, well, I need to combine these two data sets together. So to be very clear, I need to somehow join these two data sets. But the waste sites, the points on the right, they don't have any attributes that I can join on. Right? There's no watershed ID associated with my sites. These are just raw data values that were measured and collected, and they had a latitude and longitude associated with them. And for the watersheds, of course, like there's nothing to tie the data back to. So how do I go ahead and build a map like this, which I'm actually showing both the sites and the concentration, using the concentration of sites within each watershed to color the watersheds? Well, if I go back to my data source, this is where I make the connection and look at the schema for my data source. You can see I have the watersheds table here on the left, and it's joined to the hazardous waste sites on the right. And when I look at the join condition, I want to point out that there's one very complex operation called intersects, which is used in this case as the join predicate. So intersects will basically tell you which sites actually fall in the boundaries of the watersheds. So which watersheds contain the sites. And intersects will understand this spatial relationship and allow you to create that join. So here I can just, let me bring off the sites so you can see the full view. And if I hover over a mark, I can see that there were 6,700 possible sites in and around the Twin Cities area and so forth. So this capability in Tableau we call spatial join, and it allows you to spatially aggregate point data to the level of a custom geography that you supply. So you need to have two spatial files that can be brought together to do this kind of operation. Now, here's a view that's looking at schools and parks and their proximity for the city of Seattle. Now, I just showed an example in which I was working with spatial files. In this case, I'm going to work directly with SQL Server. The advantage of working with SQL Server is that I have this live connection to the database, so my data is always up to date, but I can leverage the spatial capabilities of the database, of which there are many. Let's go ahead and look at the data source, how it was constructed. In this case, I'm using a custom query to the database to do a number of things to bring in this spatial data. You can see that I have the S, the schools, and the P for parks tables, but I'm also supplying a buffer because both of my data sets are points, and I want to represent some area around these points to answer the question of which schools have parks that are nearby. And I'm using a buffer, and I can also supply a radius into my query so that I can dynamically change the size of the buffer around the schools. I'm using intersects to join these two data sets, which both exist in my SQL Server database, to bring them together. I've also buffered the, right here, a 200-meter buffer around each of the parks just to represent the point a little bit more. So if I cancel that and go back to my intersection of schools and parks, here you can see there is a school called Green Lake, and it is close to two parks in the region. But I can use that dynamic parameter to expand my search to be, say, 800 meters, and I can see all of the parks that are in and around the schools. And of course, the schools get a little bit darker blue the more parks there are. What also is interesting here is you'll notice that some of the parks, they aren't showing the full buffer. They're kind of cookie-cuttered, only showing the outline of the buffer that falls within the school's buffer. So how is that happening in Tableau? Again, this is really just a showcase of how to leverage the spatial capabilities of the database. And here, I've built a spatial calculation so I can return a new spatial object, something that didn't exist in the database, but I'm using the intersection operation, which basically says return only the spatial area that intersects with the spatial geometry that's supplied, which is why it's like a cookie cutter and just cuts that shape. So intersection, just like intersects, and these other spatial operations are all supported by the database and exposed in Tableau in these simple calculations that you can write. And of course, they can all be made dynamic using parameters. Now here's another example that I want to show. This example is using the new 2019.2 beta and shows support for Postgres spatial data. So again, very similar to SQL Server, although the capabilities between the two databases are slightly different. Now, a few things I want to highlight about this map of Boston. You can see that I'm looking at a map that has a lot of things that have sort of this gray or yellow color right now. And that represents household income for those regions. Now, this data is in the background map. It's static. It's not a spatial file that I brought into the view. It's also something that's built into Tableau. If you're working with data in the United States, we have a number of built-in socioeconomic variables that you can display at 4 different levels of geography. So I could look at county level geography, zip code level geography, or a very fine-grained census tract level geography with a choice of color palettes as well. So now I have a sense of the income distribution of the region. Well, one thing I wanted to look at was an object of interest for the city of Boston. And again, I was looking at open data sources, and I found a data source of trees in the Boston area. And I was wondering if there was any relationship between income and the amount of trees in the area. Well, one way in which you can visualize how trees are located in the region is just simply drop on all the points. But the thing I wanted to do was show off this spatial operation supported by the database. Let me show you the calculation. So in this case, I'm going to use a concave hull to display the aggregate of all the tree data. Now what does that mean? I'm going to show the minimum bounding area, the minimum geographic region in which all of the trees are located at first. Let's bring this onto the view. So here, the rough municipal bounds for the city of Boston, and yeah, there are trees everywhere. But with concave hull, this function supported by the database, I can adjust the precision using a parameter. And notice, as I adjust it, it starts to carve out places in which there are no trees and only surround the area in which there are trees. Now, the thing I want to highlight about this particular use case is that, remember, I'm looking at trees, but this could be any number of things, right? This could be a particular type of crime. This could be incidents of the flu or a disease that's spreading. And you can sort of get a sense of the geographic region in which it takes place and adjust it accordingly to think about where it might spread to or something like that, if you're talking about disease or maybe animal migration or something like that. Again, a number of interesting use cases become apparent when you can leverage these types of spatial operations. Now, also in the upcoming version of Tableau and some more advanced capabilities I want to show is we're going to do more in this area of spatial calculations. Now here, I'm looking at a table which shows origins and destinations, right? It's very common for people to want to map 2 points, point A to point B, the start to the end. And in this case, you can see I have rows that look like Boston to Augusta. And these are really flight routes, right? Like where planes are flying between. Now, how do you build the type of map that shows the flow or these types of routes, right? I want to show point A to point B and the flow of something, some measure. Well, I'll show you how to do that in this upcoming version of Tableau. Here I've built a calculation that exposes 2 spatial operations, make line and make point. Now I want to be clear, this data set is not a spatial database and we're leveraging something outside of Tableau. Make line and make point are supported by Tableau natively. And this will allow you to turn your own latitude and longitude data into spatial objects. And once they're spatial, you can then spatially enable your sort of traditional data sources like text files, CSVs, and Excel tables. Or you might have a database table that doesn't include a spatial column but has latitude and longitude fields in separate fields, right? MakePoint allows you to turn those into a spatial object and bring them into Tableau. And MakeLine simply takes 2 points and makes a line between them. Let's say OK. So when I bring routes onto the viz, I can instantly see the lines and the flows between these two objects. Again, you could produce a visualization that showed the flow of import-export goods between countries or immigration between countries. In this case, I'm looking at these flight routes, but you could also build more local things like, if you're into the bicycle share or scooter sharing business, you could show how the start and end points of particular rides or something like that. Very easy with this calculation. So again, all of that data is stored in one row. And then I could simply drag on my metric onto the viz. I could bring it onto color. This metric might be showing number of passengers or length of flight or some other aspect of the flight, expected delays or something like that. But again, very easy to show this kind of map and build it up. Now, why I mentioned the latitude, longitude, and the ability to create points from them as being important, well, let me demonstrate one example. So again, here we are back in Boston, and I have a data set of 311 calls. So this is a historic data set, all these 311 calls. How do I look at this data and sort of make sense of it if I'm someone who works for the city of Boston, in this case? Like if I'm a planner or someone who works with operations. Well, I might want to look at the neighborhood level or a planning district level, something that's relatable to how the city is organized and governed. Well, in Tableau now, if I jump back to the data source, you remember I showed that intersects operator working between two spatial data sets. Well, the 2019.2 beta version, which is available for test right now, will include this operation, MakePoint, and expose it in the join dialog so that you can do these types of spatial joins with a non-spatial data source in which you're creating the spatial objects. So if I jump back to my 311 calls and I bring the planning district geometry onto the viz, just like that. I'd already had the viz set up to show number of records, and I can see where 311 calls have taken place. So now I am spatially enabling those non-spatial data sources. The next demonstration I want to show is the ability to explore and interact more with the data directly. And one of the things that I've found a lot of people who work with geographic data want to do is to drill into the data, to change the level of detail. Because geographic data has this natural hierarchy about it, right? Countries have states, states have counties, and so forth. And of course, those are different terms in different countries. Here we are looking at a map of Rwanda, and I can use one of those parameters to change the level of detail of the viz. I can flip it to district, sector, and you can see this very fine detailed geography when I go down to the cell level, right? So parameters can allow you to flip between the level of detail in the viz. That's awesome. Another way to do that is to use an interactive method called set actions. Now again, I'm not showing you the full how-to. There is plenty of documentation through the Tableau website and through the Tableau community that will explain how to leverage this amazing capability. But I want to show you really what's possible. In this particular view, again, I'm looking at Rwanda, and I want to drill down into the level of detail, though, without leaving the viz. I don't want to use a parameter. I want to see something, and I want to touch it and change that detail on the viz. Well, now I can. I simply click a mark, and it will filter out the rest of the view and drill into it. And if I do it again, it goes into a level deeper. And if I do it again, you can see it now shows that cell level down at the finest grain, and it's doing the filtering as I go. And if I want to reset the view, I can simply tap the marks and come back out. So there are many ways in which you can create an interactive experience for exploring spatial data And spatial data has these natural hierarchies, which really lends itself well to these drill-through scenarios. Let me show you another example. So here we are looking at detailed geography for the city of Sao Paulo in Brazil. I'm looking at both districts, and I can flip it to sectors, which is kind of like census tracts in the US. So very detailed geographies. But sometimes I don't want to see all of that detail all at once, right? Or I don't want to see sort of this higher level view all at once. I might want to look at one particular item. Well, that's again possible using set actions. And I can asymmetrically drill into this data set. Now what that means is I can look at the finer level of detail for one district without changing the level of detail for the entire viz, simply by clicking on the mark. And you can see how I've turned this particular mark into all these smaller subgeographies. I'll zoom in to highlight this example. So if I click on this viz, the rest of the surrounding regions are not going to change. Sorry, if I click on this mark. And there you can see it. So there are ways in which you can explore any of the measures or variables that you're looking at for the geography that allow you to drill into it, maybe explore that question, maybe consider another way of looking at the data, and then you can, of course, drill back out to the original view. So this kind of interaction can create new ways in which you can really explore the data. And of course, for all of these kinds of features, these interactive features, they're useful on maps and non-maps, of course, right? You might have products in a product view and look at a bar chart that includes products and categories and subcategories, again, a natural hierarchy, and create the same kinds of drill-through experiences. Excuse me. I'd like to show a few ways in which you can control and define the context for your analysis. So Tableau comes with 3 built-in styles in the 2019.1 release: a light, dark, and normal map style. Right now we're looking at the light style, and I can change that to normal or dark. Now the upcoming release of Tableau will include 3 other styles, like a Google Maps-like street style, an outdoor style which emphasizes green space and has topographic contours, and then a satellite style showing imagery. Let's jump back to the light style and just consider this visualization. I'm looking at police precinct data for the city of Columbus. Now in this particular view, this might be fine for a most general audience, but in the city of Columbus, people want to work with their own map layers. So they have many different map layers, and they've published these layers to their own services. In fact, I can zoom over here to the maps.columbus.gov website and find an ArcGIS server endpoint that displays all the services available for the city. So if you work in an organization that has ArcGIS installed, there are ways in which you can bring ArcGIS maps into Tableau, and I'll show you. Here I'm just navigating to a city-supported base map, and you can see that it has support for standards WMS and WMTS. You can connect to both of these maps in Tableau. I'm going to go ahead and connect to WMS because it has an easy, out-of-the-box URL input. So when I go to the map, background maps, and say map services, I can simply add a WMS server, paste in that URL, and you see the map automatically updates and is now showing data being served by this public-facing web map service from the city of Columbus. When I go to my map layers pane, now all the layers available in this map are being served by this map service from the city. And you can see how they turn on. So again, you may have a mandate to use your local agency's data, or you have the authoritative data. Well, it's easy to bring that into Tableau so long as your map service supports one of these common standards like WMS. Now another way in which you can show a custom map background is using MapBox. And in Tableau, we've made it super easy to bring in your own content from MapBox. Now MapBox is a great platform Again, I'm just showing you the same way in which you would do it. You could say add MapBox Maps here, and you would go ahead and paste in the map from your own MapBox account. Now, MapBox gives you a few different things. You can see from this map here that it has completely different cartography. You can control every element of the map style itself, color, font, and so forth. You can filter out data that's not relevant. You can also add your own data. So if you have a data source like your sales territories, of course, Tableau is never going to have that in the view, but if you have it, you can upload that into your own map style and create the right contextual background map for your data analysis. So I think it's a great way of showing and setting up the context for your data. It also is great for sort of storytelling purposes. If you're a journalist or trying to tell a story about a data set, this gives you more artistic control and really lends itself to the themes in which you might be telling the story. Okay. Now there's one more thing that I want to get to, and it is a really great and powerful capability, sort of along the subject of you having control of the analysis and you having control of the context of your data. Well, in the 2018.3 release, Tableau made available an extensions API. This allowed you to create your own sort of lightweight web application that you could run inside of a Tableau dashboard. So again, there's so many different workflows that your own organization might have that Tableau, again, is building more generic capabilities to support. But if you have this specific custom workflow or visualization or capability that you want to implement, you can go ahead and do that through extensions. And in this case, where I'm looking at pedestrian and vehicular traffic for the city of Toronto, I'm going to go ahead and add an extension object to my dashboard and bring in my own analytics capability. So this particular extension was built by our friends and partners, MapBox, and I can go ahead and run through their user experience and look at pedestrian volume for the city. So you can see they've added this own map. There's this new map that's added to the dashboard, and I can configure how the data is visualized. I can choose square bins. I could choose Voronoi diagram, which shows equidistant polygons around individual points. Let's go back to the square bin, which I can define a specific radius. I'll pick 2 miles. Of course, I have choices for colors and for classification, so I could use natural breaks or quantile. Let's go ahead and do that. And then I'm just going to define an extrusion height as well. So you can see now I have this bin view of the data available to me in Tableau. But of course, I did set an extrusion value, and if I wanted to, I could actually view this data in 3D. Simply push the awesome button, and now I can visualize the data in 3D. And then of course I could even select data over here, and it filters the view on this side. So it's really an interactive piece in the dashboard. So with extensions, right, you can now bring in your own capabilities, your own type of analysis into your dashboard, and this might be the most relevant way for you to expose certain workflows and capabilities within your organization. So with that, I'm going to sort of jump back into the slide deck. Whoop. And stop sharing my screen and hand things back over to Stephanie, who can MC the rest of the session. Thank you.
Ken, thanks for that excellent presentation. So we'll get started with today's Q&A session, and I want to thank the audience for their participation. We've got a great many questions that have come in during the presentation, and we'll do our best to get through all of them in the remaining time. During this Q&A session, I'll leave up this screen with contact information for Ken if you'd like to contact him following today's webinar. All right, so let's get started, Ken. How does Tableau support data stored in projected coordinates?
Yeah, that's a great question. So when it comes to data that comes from a spatial file, so if you have a shapefile or KML or a map info table, that includes projected coordinates, so where the data might be stored in like a state plane coordinate system or the local coordinate system used in your country. The way that that data is ingested into Tableau is it goes through a conversion process, and all of the data is normalized and converted, transformed to WGS84 coordinates, and displayed on our Web Mercator projection. So we use the standard Web Mercator to view data inside of Tableau, but all of the coordinates are latitude and longitude coordinates when they come in. So if your data is stored in, say, feet or meters or other units that are associated with other projections, Tableau just handles that on the ingest and transforms the data, reprojects the data to be rendered in Tableau.
Okay. Similar question about measurement, really. Would there be a way to show how many miles the line represents?
Yeah, if, I'm just going to share my screen again because I can. And I can jump back into a view here. If I bring on city onto this view, and you are more interested in sort of a distance measurement, you can use the radial select tool inside of Tableau. And if I zoom in just a little bit at the local level, you can actually see the measurement value increasing. So you can actually go and interactively measure a distance in Tableau. There's no specific measurement tool, but you can use this to do it interactively, and you can also write your own calculations that will allow you to measure distance. So in the Tableau community, in the Tableau forums, there's lots of talk about how to use distance and how to measure distances between latitude and longitude, and that's all possible, but you would do it through a simple calculation. Stephanie, I'm just going to leave my Tableau up here while people ask questions for a few minutes in case I need to use the software.
Okay. All right. Sounds great. So this is a little bit lengthy, but it's kind of an interesting question. The user has 3 sheets mapping villages that were surveyed in Senegal, one with major towns, one with villages, one with roads. They're from different databases. 2 databases are from administrative data. They want to know, how can I layer these 3 sheets into one map? They want to be able to see the relationships between villages, cities, and roads.
Yeah, that's a great question. So I will say a few things. The first is Tableau may be reducing the need, in this particular case, to have your own road data, because we are completely updating the base map content in Tableau to provide more detailed data sets within our maps. And roads and points of interest are some of those data sets that should become updated. Now, to answer the specific question about how do I support layers amongst 3 different independent data sources, so Tableau has a limitation in terms of how many layers you can have. I showed a view here in this particular map earlier where I was showing 2 different data sources, right? I had the point sites and then I had the actual watersheds. And this is using a function called dual axis maps, which I can show you from any one of the pills on the columns or rows shelf. Now, dual axis maps allow you to have 2 layers, but the data sets still need to be joined together. I will say, so again, just to be clear, you can't just connect to 3 independent data sources and bring them onto the same sheet. The only other sort of workaround to that is to use sheet transparency and align multiple sheets on a dashboard. This, again, isn't the type of implementation that will scale well. It's just not going to work if you do resizing or things like that, or you want to interact with all of the layers. It would only allow you to really do interaction with that top layer. So again, that's a bit of a workaround if you just want to visualize the data. Otherwise, you might need to union the villages and the towns into a single table, and then connect that with the road data so that you only have the 2 tables together. How would you do that union? If they're in a SQL Server database, you can union the tables. If they're 2 spatial files, you might need to use an external GIS tool like QGIS. And the way you would connect them then would be, again, a bit of a workaround, but do a full outer join on the roads and the point data, and then use your appropriate filters to display the data on a map. I want to say long term, we know how important layers is in the community, and this is something that we get this question asked a lot, and something that we're doing active research on, and that we even spoke about during the Tableau conference in 2016 as one of the future items that we are looking to invest in. So I would say stay tuned to sort of early product releases and opportunities to test upcoming features that are going to be released in Tableau. And that information that comes with those early releases will include sort of some of the innovation that's coming. So hopefully we can get to this sooner rather than later. Thanks for the question.
Alrighty, so how many different data sources can you link to?
How many different data sources can you link to? Yeah, in this view here, right, where I was looking at Rwanda and looking at different levels of detail, you can see that I just simply joined the spatial data because shapefiles can only include a single spatial column, whereas like your database table can include multiple spatial columns. But I just joined these 4 tables in this case. There's n number of, it's unbounded number of joins that you can make. But of course, if you're working with millions and millions of rows of data and, doing these kinds of joins, the performance might degrade with a live connection. You may want to build an extract of the data. So the connection type being an extract as opposed to a live connection. But of course I can have, let's see, in this case, I have views here where you can see I have 1, 2, 3, 4, 5, 6, 7 different data sources in this particular workbook. So I could use all of those workbooks. But if you're talking about a specific sheet, again, you need to have a data source in which the data sets might be linked together, and then you can leverage all of the fields available after the relationship has been established. I hope that answers the question.
Okay. Can those connections be both live and extracts?
So for a data source, you have to choose one or the other. So right now you have to pick either live connection or an extract connection. I think that would be an interesting sort of problem to solve, to have a larger container for the data, like a data source connection that was sort of sat above the data sources, and you had more fine-grained control as to whether or not one connection was live or not, and one was extracted or not. But that currently is not supported in Tableau. You have to pick one or the other for the data source.
Okay. All right. Next question is, how would you make routes off of an unknown amount of points, but by unique ID fields?
How would you make routes off of an unknown number of points? So the number of points isn't really important. But if you're talking about an unknown number of points that make up one route, so if you had like a GPS track that went, that had maybe 10 points along the track, like a hurricane is often tracked every 4 to 6 hours through some of the national weather services in the United States, and so it will have all these points. So if that's the question you're asking, Tableau supports a path mark type. So if you go to make a line and use this path shelf, so in this particular viz, obviously it doesn't make sense because I already have the data combined into single lines. But you can use the path shelf and an ID for the route. So let's see, actually, if I did ID for the route, it's just going to make my data a bit wonky in this case. But that will allow you to do an n number of points for the route. I would suggest looking up the Tableau forums or in the Tableau community and look up how to build visualizations that look at hurricane paths, because I know we have some examples that are available that would follow the same pattern of using the path shelf for the line mark type.
Okay. Well, Ken, thank you very much. There's some great answers to some very good questions. For those of you that asked questions that weren't answered today, We'll be sending all unanswered questions to Kent and the Tableau team so they can follow up with you after today's webinar. I just have a few quick announcements. Please mark your calendars for March the 14th, 2019, and our next DSC webinar, Patterns for Successful Data Science Projects. Also, today's taping will be available for on-demand viewing later today and can be found on the homepage of Data Science Central in the Webinar tab, located at the top of the page. Past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. This brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Tableau for their sponsorship, as well as our speakers today, Kent Marten, for his insight into today's topic. My name is Stephanie, and thank you, Kent. I'm very pleased to have been your host for today's event, and I look forward to seeing you all again on March the 14th, 2019. Have a great day.